Okay, so let us apply some of the stuff that we've learned to this problem. Okay, so what you have is you have a 0.2 kg block and you pull it by 0.08 meters and you release this block. Okay, and its ensuing motion is going to be simple harmonic motion, so we understand that. First question is determine the frequency of oscillations. Okay, the next one is find this maximum speed, and then the third question is interesting. It says, will the frequency or the maximum speed be affected if the block was pulled 0.16 meters instead of 0.2 meters? Okay, so as usual, what I'd like you to do is stop, alright, and I'll do each part along the way, and then you can just pause, check your, do the work, check your answer, and then move on. If you made a mistake, then of course you can correct it. Once again, don't be afraid to make mistakes. Just go for it. Just do it. Write it down. That's the best way to learn it. So I'm going to start with the first part of the question here. Okay. So the solutions to the first part of the solution. All right. So first question is determine the frequency of oscillations. What is the frequency of oscillation? Right. We know. Okay. It's a mass spring system. So we know A, acceleration, is equal to negative k over m times x. Right, and this problem k is given. K is equal to 100. Okay, so it's equal to negative 100 divided by m, and m happens to be 0.2 times x, so which makes this equal to negative 500 times x. Okay, now as soon as we have this equation, a equals to negative 500x, we can immediately identify what our omega is. Omega square is going to be equal to 500. Remember, the common mistake people make is, they put the negative signs there. Don't put any negative signs. Compare with A equals negative omega square x. So when you compare it, omega square happens to be 500. So this gives us omega is square root of 500. Okay. As soon as I know omega, I can find my frequency. Frequency is omega divided by 2 pi, which is equal to square root of 500 divided by 2 times pi. So we have the frequency. Okay. Part 2 is asking for the maximum speed. Now if you recall your equations, alright, the V happens to be equal to negative A times omega times sine omega t plus phi. So clearly we know what the maximum speed is equal to A times omega, the amplitude times omega. Now in this problem, how much is the amplitude? Okay, if you look at it, it says that, hey, we pull it by 0.08 meters. So that is the amplitude. So A in our problem is 0.08 meters, okay, 8 centimeters, and omega is already square root 500. So we know that. So this gives us V max. V max is simply the product of A and omega. So 0.08 square root 500 meters per second. You can evaluate, calculate these numbers. Okay. Now the third question is asking what would change. Okay, whether the frequency would change or whether the amplitude would change if, not amplitude, the maximum speed would change if we change the amplitude. Okay, so let's ask this question. What is the frequency? Frequency is equal to omega divided by 2 pi, and it happens to be equal to, so 1 over 2 pi square root k over m. Okay, the frequency is completely independent of the amplitude. When I change the 0.08 to 0.16, I'm effectively changing the amplitude. Okay, and frequency does not depend on does not depend on the amplitude. For the mass spring system, completely independent of the amplitude. Okay, so it doesn't matter. So if the frequency does not depend, then we know that F will continue to be the same. So F will still be equal to square root of 500 divided by 2 pi. So it does not change, remains the same. Let us look for the speed. On the other hand, the maximum speed on the other hand is equal to A times omega. You see here, it depends on the amplitude. So when we change the amplitude, we are changing the maximum speed. Now this should make sense also physically, because when we change the amplitude, when we increase that, we've essentially poured in more energy into the system. And if we're pouring in more potential energy, at some point when the potential is 0 and it has all kinetic, all that kinetic energy has to increase. So it's going to become larger than what it was in the beginning. And by actually doubling it, we've quadrupled the potential energy and hence quadrupled the kinetic energy and hence doubled the speed, the maximum speed. So this will be 0.16 times square root of 500, which is equal to 2 times V max old. Okay, so this should all make sense. Same thing with the acceleration. The acceleration is also going to be doubled. Okay, and clearly by doubling the amplitude, we are doubling the force. Okay, the maximum accelerations are going to be increased. So once again, remember, this is the maximum acceleration, the velocity. This is not the velocity at any other point. Okay, this is the maximum velocity, which happens to be the velocity at its equilibrium position. All right, so that's that.